This recording is to help you with the Section 2.1 homework, and so what you should do today is watch this recording and then finish the Section 2.1 homework, which is due for Tuesday morning. So the first question in Section 2.1 is like the last example that I did in class, where you have a table and it has time and it has volume and it has the volume for various different times from 5, 10, 15, 20, and 25, and it has the volumes down here. If you go back and you look at the last example that I did in the class, I'm just making up some numbers here. That's 1,000. That is absolutely terrible. So 1,500, 1,000, let's say 750, let's say 400, and 250. And it asks you to find, it says if P is the point on the graph, that is the point 15, 750, then find the slopes of the secant lines when T is 5, 10, 20, 25, and 30. So to find, for example, the secant line, the slope of the secant line at T equals 5, you would do f of 15 minus f of 5 over 15 minus 5. The 15 came from right here, and the 5 came from right here. So then f of 15 is this number, 750. F of 5 is this number, 1,500. And then 15 minus 5 is 10. So I believe that is 600 over 10, which I believe is 60. And then it says to approximate, so part B is estimate the slope of the tangent line at P by averaging the slopes of the two adjacent secant lines. So you would find the slope for 10, the same way you had it here, and the slope for 20, and you just average those together. So that's problem number 1. All right, let's take a look at problem number 2. Problem number 2 gives us a function. So let's say we had curve y equals, and I'll just make one up here, 4 over 5 minus x and the point 1, 1 is on that graph. And so we're supposed to find the slope of the secant line for the following values. So like the first value I would use would be 0.99. So the way you would do this is you would say f of 1, let me use a value other than 1 so you'll know which one I'm talking about. So let's say I have -3. So if I had -3, this would be 0.5. So let me do one that has numbers that are more to my liking. Sorry, let's see. Let's do 3. And then that would be 4 divided, that would be 2. There we go, that's better. Okay, so now let's say I want to, my point that I'm supposed to find the secant line is 2.99, or 2.9. So 2.9, which is a number close to 3. So I would take f of 3 minus f of 2.9 over 3 minus 2.9. So just using these x values here. F of 3, you plug 3 into y, but I already have that, f of 3. This is f of 3 right here. I know that that's 2. f of 2.9, I get that by plugging 2.9 into here. So this is 4 over 5 minus 2.9, which is 4 over 2.1, which is 1.9, well, it says to 6 decimal places. So when it's to 6 decimal places in your intermediate values, carry them out to at least 7. So 1.9047619. So if it says to 6 decimal places, keep your intermediates at least to 7. I just use the value that's in the calculator. So I just copy it from the calculator. I don't necessarily do the writing it down. 1.9047619 over 0.1. And so then what I do, so I had 4 divided by 2.1, and then I need to have 2 minus that. So 2 minus, now on this calculator I can go up and highlight and press enter, but on any TI calculator you can do second and the negative sign is answer, and it pulls up the answer from the last problem. So it's that. So that is my value when I do the subtraction, and if I divide that by 0.1, I get 0.95238, and you have to round correctly. So 0.95238, and then on the calculator it says 0.9, so I'd round that to 1. So that's all you have to do for these, and unfortunately there's a bunch of them that you have to do, and you just have to get the results, and then you look at all of the results, and then based on the results you come up with your estimate as to what you think the slope of the tangent line is. So for instance, if I do the same one with 3.0001, so I'll do 2 minus 4 over 5 minus 3.00001, and then divide that by 3 minus 3.00001, and I get 1.00005. On this particular problem, and so my guess would be the slope of the tangent line at x equals 3 is 1. Now I want to double check this, so for those of you who've taken calculus, you can pay attention. For those of you who haven't, don't worry about this. So 4 over 5 minus x, so f of x equals 4 over 5 minus x. That's the same as 4 times 5 minus x to the negative 1. So the derivative is negative 4 times 5 minus x, and then the chain rule minus 1. So that is f prime is 4 times 5 minus x. Now if I plug in 3, I get 4 times 5 minus 3 is 4 times 2. This should have been to the negative 2. That explains this problem. To the negative 2. 2 to the negative 2 equals 4 over 4, which is 1. Okay, so that is correct. Alright, so, but you can ignore that part for now. Okay, so then it asks to find an equation of the tangent line. So the equation of the tangent line, y minus y1 equals m times x minus x1. Well, you have your point. Your point is the point that was given 3, 2 in this example. and the slope is the slope that you calculated, and then you just plug in. So y minus 2 equals 1 times x minus 3, and then you solve that for y. So y minus 2 equals x minus 3, or y equals x minus 1. Okay, and then the next problem, a ball is thrown into the air with an initial velocity of 48 feet per second. Its height in feet after t seconds is given by y equals 48t minus 16t squared. And we want to know the average velocity for the time interval beginning at t equals 2 and lasting for each of the following. So for part I, it says for 0.5 seconds. So velocity is the rate of change of position. So what we're looking for is the velocity is going to be the position at time 2 minus the position at time 1 over time 2 minus time 1. And so at time t equals 2, if I plug in 2 here, I get y equals 48 times 2 minus 16 times 2 squared. That's 96 minus 64 is 32. And then at 0.5 seconds, at t equals 2.5, you would have y equals 48 times 2.5 minus 16 times 2.5 squared. That's supposed to be a 2.5. And I get 20. So then my velocity will be, time 2 is 2.5, so it would be 20 minus 32 over 2.5 minus 2 is negative 12 over 0.5 is negative 24. And then my units of distance were feet, and my units of time were seconds. So this would be negative 24 feet per second. And then it has you go through and do it for 0.1 seconds and 0.05 seconds and 0.01 seconds. So you do the same calculation, and then you look and you see if you're getting to any kind of consensus value, and then that will be your answer to part B, to your instantaneous velocity. These are average velocities. The instantaneous velocity would be the slope of the tangent line, and so whatever number it seems to be approaching. And then for question 4, it says it gives you a table. And the table has t in seconds and position in feet. So I just made up some numbers there. And then the problem is asking you to come up with the average velocity on different time periods. So we would say the average velocity, say, on the interval from 1 to 3. So the average velocity on the interval from 1 to 3 would be the position at 3 minus the position at 1 over 3 minus 1. So the position at 3 in my table is 20 point whatever number I wrote there, minus the position at 1, which is 5, over 3 minus 1, which is 2, and that value is 7.95 feet per second. And then it asks you to estimate the instantaneous velocity when t equals 3. So you could find the velocity, average velocity from 2 to 3, from 3 to 4. You might also find the average velocity from 2 to 4, and maybe average those numbers together and see what you come up with. Feel free to use a graphing calculator to help you with your calculations, or Desmos. So like for instance, if I go to Desmos, let's see if I remember how to do this. So if we have our function, so we would say whatever our function is, f of x equals 3 divided by x minus 7, and then we'll add a table of values, and I'll make this x, and I'll make this f of x, and then if I need to get the values, so if I had 2.1, 2.01, it'll just get the values for me, and then I can make another column where I could have 2.1 minus x, so, and then I could have another column where I could take my f of 2, which was, or f of 2.1, which was, let's see, oh no, I wanted to do 2, so 2 minus x, so 2 minus x, so that's my denominator, and then I want f of 2 minus f of x, and that gets me that value, and then I could have f of 2 minus f of x over 2 minus x, and then it does the entire problem for me. So that's kind of cool. So it saves you a little time. Alright, well I hope this is helpful. So what you should spend your time now on is doing all those calculations for section 2.1.